Okay, let's take a look at domain and range. We're first going to look at just domain. So when we take a look at this, we're only looking at the x values. Domain meant the x values. Okay, this is the easiest way for me to explain what happens here. Take your pencil. This is your pencil right here, this little red thing. Take your pencil and follow along the graph. So when you follow along the graph on this domain, on the graph number 1, I want to go all the way to the left. So I start everything from left to right. So I start to the left, and I want to see how far does it go to the left, or where does it stop on the left. And I can clearly see that they put an arrow here on the left-hand side. Okay? So my domain goes all the way to the left. And then if I continue following the graph, it keeps going on the graph, keeps going on the graph, it's still on the graph, still on the graph. And then I want to know how far does it go right, or where does it stop to the right. Well, this clearly has an arrow all the way to the right as well, which means that this answer to this domain is all real numbers. Any number that I can plug in to this graph will come back and give me a point back on the graph. There are no values of x that I can't plug in that won't come back on the graph. Well, that shows up when we have nice little functions like y equals mx plus b functions. Okay, this is a nice little straight line. There's nothing that I can't plug in that won't come back just fine. And we'll take a look at those functions in terms of equations. Again, we took a look at just plugging in numbers, but we never named the domain on those. Now we're taking a look at just the domain, and we'll start with the graph idea. So when I look at this graph, I see that the domain is all, and I write that like this. I say the domain is all real numbers. Okay? So then I'm going to move on to my next one. Okay? So I'm going to number 2. Here's the graph. Well, furthest to the left, the graph goes all the way up to the left-hand side. So again, it goes all the way left. To the right, it goes all the way to the right. So the domain is exactly the same. So if I take this and I clone it, it's exactly the same thing. Okay? The domain in this problem is all real numbers as well. Okay? Go ahead and take a look at number 3, and then we'll jump down here to number 4. Number 4, where I'm going here is I'm following my pencil. Here's where the graph actually starts, is right here. Okay, the graph actually starts at -4, and so I'm not going all the way to the left, and so I need to somehow notate that, and so we'll look at that notation in a second. But it goes starts at -4, then I'm following the graph, and here's where it ends. It ends over here at 2. So I need to write that as an inequality, that it starts at -4 and ends at +2 and has all the numbers in between. That sounds like set builder notation. So set builder notation says the domain is x such that x is between -4 and 2. Okay, it doesn't go away. So even though on the last test we didn't do so great on it, we have to be able to know that this happens. Okay? Number 5 is very similar. I want you to do number 5 by yourself. Number 6, I'm going along and it starts here at -4. Okay, and goes and goes and goes and goes and goes. And there's a jump here, but there's an open circle and a closed circle. The closed circle here actually is a value, and so my graph still is going from left to right. It has a jump from up and down, but that's not domain. Domain is only left and right, so that's the x values. So my x values still are valid here, and it goes all the way to 4 over here. So it goes from -4 to 4, and so when I actually write that, it looks a lot like this set builder notation, but it's just a tiny bit different. And the difference only is because it goes, this number 4 stopped at 2, number 6 stops at 4. There's no difference in it in the rest of the notation though. Okay? We've done all of the problems that are similar to that on the front of the sheet. Now let me grab my handy dandy pencil here. You can go to the back of the sheet. Well, when I go to number 14 though, it's a little bit different. I find the start of my graph and it starts here at -5. Then it goes and goes and goes and goes and goes and goes, and all the way to the right it goes on forever. So I need to have a way to write that. So it starts at -5 and goes on forever. Well, the way that I write that is with, again, the set builder notation and some except that I'm only looking for the numbers that are bigger than or equal to -5. Okay, I started over here at -5 and I'm going on forever. And if you put the inequality with -5 at the start and infinity as the end, technically, mathematically, it's not incorrect, but I'm going to start marking it wrong because I want you to write this in a more concise way. We want to be a little bit more lazy about it. Okay? So then when I come down here, I've got a couple different ones. This one starts at -6 over here and then continues until -3. And then it has this huge jump in here that there's nothing in here for me to follow on my pencil. So I need to put an or in there so that I know that it's either over here or it's over here. Okay? So I need to have both of those in there. The second one starts at 2 and ends at 6. Okay? So I'm going to put both of those things in my idea here of the graph or the domain. And so the domain actually gets pretty long for that one. X such that -6 is less than or equal to x, less than or equal to -3, or 2 is less than or equal to x, less than or equal to 6. I have to have both of these portions in here in order for me to properly label the domain. And then on 17 is the last one that we kind of need to look at here. All the rest of them follow along with things that we've done already. The 17 goes here. Here's where the first point is at -4. But I can't follow this graph. It jumps. So it jumps to -2, and then it jumps to 3, and it jumps to 5. There is no continuation here. So I can't use these inequalities because I'm not talking about all the things that are in between there. I'm only talking about those specific points. And so in order to write the domain that way, I have to use roster notation. Okay, roster notation is different than this idea of the domain and range with set builder notation. Set builder is all of this stuff in between. I want to use roster notation because I'm not talking about all the stuff in between for this one. And so my domain ends up looking like this. We will come back and do the range on another video, but here's the domain idea. X is left to right, going through, starting at the left, follow your pencil along, see where it stops. If there's a space, then you need to create something that shows that space. If you're jumping around, you need to show that you're actually jumping around, okay, what those X values are. Okay, that's domain.